All right, so we're going to do 1.33. So if you've got your book, it's probably going to be easier for you to just follow along. So essentially what they're telling you in 1.33 is that you've got 35 billion tons of carbon dioxide. And they want to know what that is going to be in grams of CO2, and they want you to write it using a metric prefix. Okay, so first thing, what do they mean by use a metric prefix? What would an example of a metric prefix be? Kilo, okay, and what does the metric prefix kilo mean? 1,000, okay, so that's what they want. They don't want you to write it in exponential notation. They want you to essentially use a whole number and then do something with the metric prefix on it, okay? Now, billion is a very large number, but there is a metric prefix, or at least an exponent that you might know, that stands for billion. What's the scientific notation, or the 10 to the power that stands for billion? Yeah, 10 to the positive 9th power. So I can say that I've got 35 times 10 to the 9th tons of CO2. That much make sense? Yes.
Wouldn't that be 3.5 times 10?
So that's a really good point. Correct scientific notation would be written as 3.5 times 10 to the 10th. I'm writing it like that to be more clear about how I turn the word billion into an exponent. That is the same thing as 3.5 times 10 to the 10th, and that is better scientific notation. Okay, so now that I've gotten it written in a number that we can actually kind of put into your calculators, because I can't type the word billion into mine, what do I do with this now? What would the next step be?
Convert tons to pounds.
Okay, so I can go through a really long convoluted process and convert tons to pounds, and I convert pounds to kilograms, and kilograms to grams. I looked through your textbook today, and I don't think they give you the conversion factor for tons anywhere, which was not super helpful, so I Googled that earlier. And the one I used is 1 ton is equal to 907,185 grams. Okay, so if the scientific notation and the math went into your calculator correctly, this is what your answer should look like at this point, just straight out the calculator. Okay, if you're not getting that, again, be careful with your parentheses. Make sure your calculator is doing what you want it to do. Any other questions about that? Yeah.
Is that correct?
That is incorrect significant figures, and it does not answer the question using metric prefixes. So this is kind of an intermediate stage right now. All right, so let's go ahead and look at significant figures, and then we can work on metric prefixes. So how many significant figures should our answer have? Only 2, which means I'm going to keep the 3 and the 1, but next to the 1 is a 7, so that 1 really needs to change into 2. So we know that the only 2 numbers that are going to be in our answer is 32. Okay. Now the question is, what is the appropriate metric prefix to use? All right. We know that billion is times 10 to the 9. Okay. But I'm still pretty far away from times 10 to the 9 because I've got 10 to the 16th. So is there a metric prefix that's bigger than a billion? Sure there is. Look in your book if you don't remember. What's bigger than 10 to the 9? What's the next one your book has in there? Tera, which is 10 to the 12. We're getting closer. Can we get any bigger? Peta, which is 10 to the 15th. And your book max is out there. There are bigger ones. So we know that a peta is 10 to the 15th power. How could I write 3.2 times 10 to the 16th as something only to the 15th power? It would become 32. Okay, so the correct answer here would be 32 petagrams okay? Because I had to move the decimal one time over since I'm not to the 16th power, I'm only to the 15th power, so that extra factor of 10 essentially gets put on that number. So instead of 3.2, it's 32 times 10 to 15, but instead of 10 to 15, we can just say 10. All right, so this is 1.65. We want to know what type of quantity is indicated. So what is even the range of my choices? What do they mean by what type of quantity? What kinds of answers could I have? Volume would be one type of quantity. Length. Time, density. Okay, so that's what they're looking for, which is just the general class of this thing. So milliliters are used to measure what? Volume. Just the normal unit of centimeters is used to measure what? Length, but if it's centimeters squared, it's area, because I'm going to have a length and a width. What about cubic millimeters? That's a volume again. Okay, milligrams per liter, that's a combined unit. What does milligrams measure? Okay, milligrams itself is mass. Liters is volume, so mass over volume means this is a good. What about PS? Time. Yeah, what does the P stand for? Pico. Yeah, pico. So what's the power associated with that? Okay, so let's go through these in order. So 10 to the negative first is deci, 10 to the negative second is centi, 10 to the negative 3, milli, then we're going to jump 10 to the negative 6, micro, 10 to the negative 9th, nano, so 10 to the negative 12. Yeah. So this represents seconds, so time. And M represents what? Length. And K is for Kelvin, so that is a all right, any questions about those? All right, for the sake of time, I'm just going to go over the first couple of these, and then you should get the idea pretty quickly. So they want to know what the SI-derived units are, given them in base units. So we know that acceleration is distance over time, okay? In SI, what do we measure distance in? Meters. Time is measured in, so this would actually be meters per second squared. So that's typically how acceleration is measured, units of meter per second squared. Talking about it for force, what do we typically measure mass in for SI units? It's actually kilograms, okay? Which is kind of weird to a chemist. So chemists use grams because things are typically tiny, right? But for most of the world, grams are way too small, so kilograms. And then we just found out that acceleration, meters per second squared. And if you actually combine those, what is the more typical SI unit for force? Yeah, so it's typically given in newtons, which is just a combination of those units.